Assalamu alaikum everyone. This is our project demonstration video of our project, and the project is titled by ECG signal denoising using digital filters and convolution-based analysis. This project is submitted by Nur Ahmed Jamil, student ID 2306075, and MD Riyadus Salehin, student ID 2306076. In this project, we built an app that can generate a real noisy ECG and removes the noises part by part, step by step, using different filters, and shows the output matrix in the app. Main function of our system is it will generate a ECG signal, then add some noises like power line interference, baseline wonder, and EMG or muscle noises, then add them up to create a noisy signal. This noisy ECG signal will be filtered through some digital filters. So there are three filters in our system. First, notch filter, then high-pass filter, then low-pass filter. And then the output will show like denoised ECG signal, and the output matrix will be shown in the app. We'll see later. The app interface is something like this. So here in the left, we can see the sidebar, which makes the app more interactive, and the content bar is almost full the window, and the status bar is below here. So we can change the signal types and noise amplitudes. Noise amplitudes can be changed, and the values are shown here. We can apply to generate the noises. Now for the coding part, we didn't use any callback functions. We used callback buttons, which are here, and then we generated our signal in this section. In this section, we generated our signals, and these functions, this generate all signals function will generate our signal. And we used the sampling frequency is as 360, and the time duration is 10 seconds. So all plots of the app will show in only 10 seconds. We used we used Gaussian PQRST model to generate the clean ECG signal, and this line is actually generates our ECG signal. And then we added noise and add them up to create the noisy ECG signal. And then in this section, we generated our filter, the high-pass filter and the low-pass filter. And after that, we used these lines to denoise our noisy signal step by step. And for the UI, we have three different parts. One, the sidebar, which makes it interactive, and then the content area. The content area shows the output plots of our different panels, different stages, and then the status bar. The status bar shows the metrics of the output signals, and these two sections update the axis and the status bar each step. Here are 12 different panels. Each panel has different functions. In the first panel, we can see the panel shows the first clean ECG signal, and then three noisy signals, and then the composite noisy signals for the for of the ECG signal. Noisy ECG signal is shown here. And then in panel 2, the PSD is shown, which means power spectral density. To show them, it is shown in the frequency domain. So the noise frequency identification can be arrived. In the panel 3, 4, and 5, the properties of the filters is shown, and the plotting code is here. In the panel 6, it shows each step of filtering. There are three steps. First, the signal goes through notch filter, which cuts the 50 Hz power line, and then the high-pass filter removes the baseline wonder, like the frequency noises, the noises below the 0.3 Hz frequency, and then it goes through a low-pass filter. The low-pass filter removes the noise from 100 to 150 Hz. And then in panel 6, uh, it it shows the convolved signal and the output signal from the filters, and compare it to show that the output signals and convolved signal and the output filter wise output denoised signal is identical. In the panel 8, impulse and step response of each filter is shown, and in convolution theorem, in the panel 9, the convolution theorem is shown here with different plots, and the theorem is shown here, written here. In the panel 10, metrics are plotted, like in each step, how the matrix is changes. Like the SNR is increasing and the RMS and PRD is decreasing after each step. In the panel 11 and 12, it is the overlay. In the panel 11, it shows the time domain overlay, which compares the clean ECG signal with the filtered ECG signal, denoised ECG signal, and shows that it is very close. They are very close to each other. The difference of each signal is very low, so the error is negligible. And then this is it. Thank you, everyone.